Hello, this is Mr. Wynn, and this lesson is 6-1, Operations on Functions. So, when you have multiple functions, you can perform arithmetic operations, for example, addition, subtraction, multiplication, division, just like you did before with polynomials. So you can look at the chart below for some examples. They give us two functions, f of x equals this, g of x equals this. They show us how to do addition, subtraction, multiplication, and division. Notice there are signs. There's an addition sign, subtraction sign, multiplication sign, the dot, and the division symbol of fraction. All right, but when you see that, the outside x goes to both of them. So this f plus g of x becomes f of x first on its own plus g of x on its own. All right, and then you either add, subtract, multiply, or divide. All right, I'll do some problems on the next slide. So here we have 2, f of x equals x squared minus 4, and g of x equals 2x plus 1. So first we're going to add this first one. This is f plus g of x. So because this is addition, the x goes to both the g and the f. So this is f of x plus g of x. Now if that x was like a 2, then it'd be like f of 2 plus g of 2. So all I got to do now is just plug this in. F of x right here goes in for f of x, and g of x right here goes for g of x. So what I mean is the problem now becomes x squared minus 4 plus, that's the first one, f of x plus 2x plus 1. Now when I do this, I gotta combine like terms. That's all I really gotta do. What combines here? I have this, that negative 4 and that plus 1. So the x squared, that's only x squared first, then there's only 2x, so that's 2x, and then negative 4 plus 1 is a minus 3. So that's my answer there. So when you add the two things separately, you should get x squared plus 2x minus 3. Alright, same idea for subtraction. This will go to both of them. This is f of x minus g of x. So let's plug them in. The first one is, and I should actually put this in parentheses, how that make it easier. Alright. The first one is f of x squared minus 4. I'm going to subtract the other one, 2x plus 1. Now the reason I put the parentheses this time, because we have subtraction. Hopefully you know if there's a subtraction sign, there's actually a negative one there, they get to distribute to both of these. So what happens is, the first one, there's something to distribute, it's just x squared minus 4. The second one is actually now negative 2x minus 2. Combine like terms, the negative 4 and the negative 2 combine this time, so it's going to be x squared minus 2x minus 6. That's the answer there. And lastly, probably the one that's confusing is multiplication. So down here, this x goes to both of them. So that's really f of x times g of x. So I plug the f of x and g of x in. That is x squared minus 4 times 2x plus 1. Now, I don't know if y'all remember, but we have something called FOIL, or what I call double distribute. First, when you have something outside parentheses, you got to distribute it in. So this x squared has to multiply both of these, and then this negative 4 has to multiply both of these. There's going to be 4 things. All right, so x squared times 2x is 2x cubed. X squared times 1 is x squared. Negative 4 times 2x is negative 8x. And negative 4 times positive 1 is negative 4. And now none of those combined, so that's my answer there. So maybe you haven't done a double distribute problem or a FOIL problem in a long time. But that's how you do it. You do not just multiply the x squared and 2x and the negative 4 plus 1. There's 4 different things. All right. Besides that, there's another method we can use to combine multiple functions, and that's called composing them. In a composition of functions, the results of one function are used to evaluate a second function. What that means is the answers of the first one is used for the second part. So right here, I want you to look at the notation. Here's what it looks like. But basically, we now have this open circle right here. It's not a multiplication sign. It's an empty open circle. We can joke around and call it fog, but that's f of g of x. When you do a function composition, though, notice this outside the x does not go to both of them. It only goes to the first one next to the g. So we rewrite that as f of g of x, and close that. So the x only goes to the g. If there's a number out there, it only goes to the g. You find that inside first, like when we did function notation, you calculate what this is, get some answer, then you plug into f. So looking at this little table over here, it says if you have something you plug in for the domain, so x, all right, you plug into your equation, you get some y. That's the range. Now, because that's the answer to the first part, we're going to use that as the domain as the x to plug into the final part. So the range of the first of g becomes the domain of f to give us another answer, which would be the final range, the final y. That's the answer we want. All right, so it'll make sense when I do a problem next. Last thing notes on here is says the composition of two functions may not exist. I'll show you one of these coming up. So be able to compose functions. I have f of x equals x squared plus 2 and g of x equals x minus 6. First one is find the f of g of 8. So this is a composition. That's not multiplication. That's not division, adding, subtracting. I'm going to rewrite that the nice way. That is f of g of 8. So basically, every time you see that little circle, the open circle, you can make it a bracket. So our job here is to first figure out what g of 8 is. So I do that problem on the side. Let's do it over here. G of 8. This means go to equation g, that bottom one, and plug in 8 for x. So it's going to be 8 minus 6. That gives me 2. So I'm now going to plug that 2 into g of 8, because we know g of 8 equals 2. So this turns into f of 2. So we're just replacing g of 8, the inside, with 2, because we just found that. Now we have one more problem. We have to figure out what f of 2 is. So I'm going to do a side problem over here. F of 2, that means go to equation f, the top one, and plug in 2 for x. So we 2 squared plus 2. Use a calculator, do it by hand. That's 4 plus 2 is 6. That's my final answer. All right, so I know fog of 8, or f of g of 8, is 6. Now what happens if I reverse it? What do I do gof of 8? So g of f of 8. Let's see if the same or different. So this is g of f of 8. So this time I have to find f of 8 first, not g of 8. Let's see what happens. Let's do it right here. F of 8. So go to equation f, the top one, plug in 8. That's 8 squared plus 2. 64 plus 2 is 66. It's a big number, that's okay. So this turns into g of 66. So now I have to go to equation g, plug in 66. So that's going to be 66 minus 6. That gives me 60. So this answer right here, I'll select this, equals 60. Notice the answers are not the same. When you change the order, things aren't always going to be the same. There's a lot of times where they're different. So order does matter. On the bottom, you can also plug in letters. So instead of plugging number to the 8, I plug in the letter M. So down here, this is telling me to do f of g of m. So we're going to find g of m first. I'm going to go to equation g and plug in m for x. So equation g to the bottom will be just m minus 6, and that's it. So then this turns to f, and g of m we just found was m minus 6. But we can plug in letters too. So our next job is to figure out what f of m minus 6 is. So f m minus 6 means go to equation f. Oh, that's a tough one. Plug in m minus 6 for x, so it's m minus 6 squared plus 2. This one needs some more space. Remember, m minus 6 squared means m minus 6 times m minus 6 plus 2. Like I did in that last slide, we had a double distribute, or a FOIL. I'm going to do this, and then this. So I'll probably skip this last part, but it's going to be a different answer if I did that. So m times m is m squared. M times negative 6 is negative 6m. Negative 6 times m is negative 6m. Negative 6 times negative 6 is plus 36, and then plus 2. So combine like terms. There's only 1m squared. Negative 6m minus 6m is negative 12m. 36 plus 2 is 38. That's the answer there. Alright, so when they plug in letters, you get letters in your final answer. Alright, how about this? Be able to compose sets of points. So instead of having equations, we use sets of points with the same idea. So the first one is find gof of 1. That means g of f of 1. So here they use a table, so I don't have to really do anymore. We're going to go to equation f, this top one, find 1 for x. So 1's right here. What's the y? Gives us 8. So we know f of 1 is 8. So I'm now going to say, okay, the inside turns to 8. We got to find what g of 8 is. So I go to equation G on the bottom. I found where x is 8. It gives me the y of 15. So we know G of 8 gives us the y of 15. So what's my first answer here? 15. All right, I'm going to try the second one. It says find G of f of 15. So that really means G of f of 15. So let's see, we're going to find f of 15. So go to equation f, the top one, 15 is right there. So that means f of 15 gives us the output of 11. So I know this is G of 11. So I go to the bottom equation, plug in 11 for x. We don't see one there. There's no 11 down there. So that means this does not exist. It's undefined. So earlier I told you, undefined. That sometimes it does not exist because it didn't have something to go to calculate. On the bottom, just finishing this slide, let's see, G of f of 0. We find f of 0 first. When you look at the top table, when f is 0, y is 13. So this means this is G of 13. When I go down to the bottom, G of 13, that also does not exist. So that's undefined as well. This happens a lot when you have a lot of sets of points like this. Alright, and the last one, let's see if it's undefined or not. This is really G of f of 14. When I go 14 for f, the top one, I see 9. So this turns to G of 9. Then when I go to the bottom, G of 9, I get 0. So this one has an answer. So this time we had 2 of them had answers, 2 of them did not. 2 of them were undefined. Alright, last slide. This one I just want to talk about. It might make sense to y'all. So here's a real life example. Suppose you go to a new car dealer and they're discounting all cars by 12%. At the same time, the manufacturer is offering $1,500 rebate on all new cars. Mr. Navarro is buying a car that's priced $24,500. What will the final price be? Or will the final price be lower if the discount is applied first before the rebate, or if the rebate is applied first for the discount? So we write the equations. Here's the discount, 12% off, and here's the rebate, $1,500 off. So we'll see what happens first here. This is where the discount is applied first before the rebate. So you see how as a D inside and then R outside? Well, if they do that, the final price is $20,060. So in the bottom case, they say, well, let's reverse it. Let's do the rebate first, is given first, and then the discount second. All right, so if you look at this, you'll notice the rebate's inside, it's first, and the discount's outside second. That comes with a final price of $20,240. So it's a $180 difference. So does that make sense? And it does. Right here's the explanation. One, the price is better than the other because the 12% is being applied to a greater amount. You rather have 12, I don't know, say 10% off $1,000 than 10% off of $100, right? Because if it's 10% off 1,000, that's bigger. It's a bigger savings. All right, and I always end with the practice problem. Here's 2 functions. Find f of g of 5 or g of f5. Answers are down there. And hopefully you got any questions. Make sure you ask me in class. Again, this is Mr. Nguyen. Thanks for watching. See you in class. Bye.